You know, there are forces deep inside our planet that are so immense, they're almost impossible to wrap your head around. They build mountains, they shift entire continents, and in just a few minutes, they can unleash more energy than all the nuclear weapons ever built, combined. Today, we're diving into the science of these giants of the Earth, mega-quakes.
But to really get a feel for this, we have to start with a question. And it's not about geology, it's about you. No, really, think about it. What would you do? Where could you possibly go when the very ground you stand on, the one solid thing in your life, just betrays you? Not for a few seconds, but for minute after terrifying minute.
To even start to answer that, we first need to grapple with the colossal forces at play here. And for that, we're going to need a whole new ruler, a new language, really, to measure destruction on a planetary scale. Okay, so the thing you've got to understand about this scale is that it isn't linear at all, it's logarithmic. So a magnitude 7 isn't just one step up from a 6, it releases about 32 times more energy. To put that in perspective, if a magnitude 6 is like a powerful hand grenade, a magnitude 7 is a car bomb. A magnitude 8, that's like a small nuclear weapon. So when we start talking about numbers like 9.0 and up, we are entering a whole other reality of destructive power.
And to really understand what that kind of power feels like, we're going to travel back to one specific day, March 27th, 1964, Good Friday, in South Central Alaska. This is our deep dive into the heart of a real-life mega-quake.
So, picture it. It's late afternoon, people are getting ready for the Easter weekend. And then, at 5:36 p.m., with absolutely no warning, the world just breaks. A massive fault between the Pacific and North American tectonic plates just ruptured. The event registered a magnitude 9.2. To this day, it's still the most powerful earthquake ever recorded in North America, and the second most powerful in all of world history, a true giant. And this, right here, is just crucial. Most earthquakes you might feel, they last for what, 10, maybe 20 seconds? 30 if it's a big one? The ground in Alaska shook violently without stopping for 4 minutes and 38 seconds. I mean, can you imagine? That is an absolute eternity of terror. What was happening under the ground was even crazier. A 600-mile-long stretch of the fault just ripped open all at once. It was like 500 years of stress that had been building up between these plates was released in an instant. The energy equivalent of 100,000 Hiroshima-sized atomic bombs, all let go in under 5 minutes. All that energy just warped the landscape itself. I mean, in some places, the ground was shoved permanently upwards. Near Kodiak Island, whole chunks of land were lifted 30 feet into the air. Just try to imagine the coastline you've known your whole life suddenly being 10 meters higher than it was just a few moments ago. But in Anchorage, which was about 78 miles away, a totally different kind of horror was unfolding. See, the shaking went on for so long that it caused something called soil liquefaction. It's this terrifying process where soil that's full of water just loses all its strength and basically acts like a liquid. The ground literally turned into quicksand. In one neighborhood, a huge landslide just caused the earth to fall away, taking dozens and dozens of homes with it. And this just shows you the scale of the destruction right in the city. This wasn't just some crack in the road. We're talking about a landslide that swallowed more than a dozen city blocks in downtown Anchorage. The main commercial street of the city was literally torn in half. And the structures that people thought were solid, that were supposed to be safe, they were just no match. This 5-story reinforced concrete JCPenney store just pancaked. The floors collapsed one right on top of the other until there was nothing left but a ruin. But the shaking, that was only the first disaster. The way the seafloor was violently thrust upwards displaced a truly enormous amount of water. And that created a second monster, a tsunami. The biggest wave was recorded in a place called Shope Bay. It was a staggering 220 feet high. That is taller than a 20-story building. And the energy from that tsunami just radiated across the entire Pacific Ocean. The small village of Chenega was basically wiped off the map. It devastated ports like Whittier and Kodiak, and its deadly reach just kept going. It caused deaths all the way down the coast in California and Oregon, and damage was even reported as far away as Hawaii and Japan. So yeah, the 1964 Alaska earthquake was an absolute monster, but it wasn't alone. It belongs to this exclusive, terrifying club, a global family of seismic giants, all born from the same incredibly powerful geological forces. And this is where they live.
This is the Pacific Ring of Fire. It's basically this long series of deep ocean trenches and volcanoes where the huge Pacific plate is grinding against all the other tectonic plates. This is the birthplace for the vast majority of the world's great earthquakes, the magnitude 8s and up. So here's how that Alaska quake stacks up. Its 9.2 is just immense, but the biggest one ever recorded hit off the coast of Chile back in 1960. It registered an almost unbelievable 9.5. Then, of course, there's the 9.1 in Sumatra in 2004, the one that triggered that horrific Indian Ocean tsunami that killed nearly 250,000 people. These are the absolute titans of modern science.
So what is the engine behind all this? I mean, what kind of geological machine can possibly generate this much force? Well, the answer is a very specific type of fault. It's called a mega-thrust earthquake. It all happens at what's known as a subduction zone. That's where a dense oceanic plate is diving, or subducting, underneath a lighter continental plate. But here's the key. It's not a smooth ride. These two massive plates get stuck. They snag on each other for hundreds of miles. And this is the cycle right here. For centuries, the plates are just locked together. The plate underneath keeps trying to move, but the edge of the top plate is stuck. It gets squeezed and bent out of shape, storing up centuries of energy, kind of like a giant compressed spring. And then, one day, that lock breaks. All that stored up strain is released in just a matter of minutes. That's when the ground shakes and the seafloor snaps back up, launching a tsunami. This whole process, this cycle, is happening right now in subduction zones all over the world. Which, of course, leads us to the final, pretty critical questions about what could happen next. Okay, so we've seen a 9.5. We know the kind of destruction that represents. But is that the ceiling? Is a magnitude 10.0 event an earthquake that would release over 30 times more energy than that massive one in Chile? Is that even possible? Well, according to scientists, the answer is yeah. A sobering yes. It is theoretically possible. Now, it would take a truly gigantic section of a fault to all break at once. We're talking about the entire length of a trench, maybe. The shaking could last for up to 30 minutes, and you'd feel it across a whole continent. The odds are incredibly, incredibly low, but the laws of physics don't rule it out. So you see, the question isn't if the next great megaquake will happen, but when and where. These zones right here, they're all active. They're all building up that strain right now as we speak. The giants of the Earth are not gone. They're just sleeping, reminding us that we live on this thin, fragile crust of an incredibly powerful and dynamic planet.